Hello, everyone. My name is Dr. Destenie Nock, and I am a part of Carnegie Mellon's Engineering and Public Policy, as well as the Civil and Environmental Engineering Department. My work focuses on sustainable energy transitions and the trade offs we make in these transitions. These trade offs can occur between equality, environmental sustainability, and our development and transition objectives. I work, so in my work, the driving research question is what are the sustainability and equality trade offs of energy transitions? So, in example one, we have a natural gas plant, a solar farm, and a hydro plant. In example two, we have a natural gas plant, a wind farm, and a hydro plant. And what we do in my group is we actually build mathematical models of the electricity system to quantify these trade offs. So, that graph that just popped up is a matrix of the different trade offs you would get between LCOE, which is cost, greenhouse gas emissions, air pollution, land use, and water consumption. And the intersection of each of these boxes is a result of our models that shows how each different electricity system, which would be the different dots, rank in terms of the sustainability. So we are doing this for the USA, and we've also done this in sub-Saharan Africa. Within our USA work, we are expanding this to look at energy burden across the US. This is a nice little map of the racial distinctions of energy burden in different regions in the US, different states. The red represents African American populations who spend more than 6% of their income on meeting their energy needs. The light green and light blue areas up at the top and in the center are Native Hawaiians and Native Americans. And then we also have our Hispanic population in the purple. So this is really highlighting how energy poverty affects different racial groups within the US and the spatial distribution of energy poverty. So one of the things that we're doing in my group is looking at how these groups are impacted by climate change as well. We're looking at the sustainability trade-offs. So moving forward, deploying wind, there's going to be some impacts on energy burden and energy poverty. There's also going to be impacts on reducing our greenhouse gas emissions and our water consumption. And we need to understand those trade-offs so that we can make better decisions about where to make energy system investments. I'm also interested in helping the world achieve the United Nations Sustainable Development Goal 7, which is increasing access to affordable, reliable, and sustainable energy for all. So over 1 billion people worldwide lack access to electricity, and this really drives a lot of the work that my team and I are doing in sub-Saharan Africa. To give you a little teaser about some of the work, again, we're building mathematical models that look at different power system investments. In this output, we are looking at how your preference for equality impacts the type of power system that you would build. On the left-hand side, we see a low equality preference. So that means that this person does not care about reaching the universal access target, and they've only decided to invest in 2 power plants near the capital city. But on our right-hand side, we have a person that really cares about reaching the universal access goal. They care a ton about equality, so they have a very high preference. And they have elected to build a hydro facility near the capital city. They've invested in transmission lines, which are those green lines, and they have distributed solar mini grids around the country and some solar home systems in the south of the country. And so one of the key results here is just actually modeling people's preferences and how those preferences would impact the ideal electricity system that different decision makers would build, and understanding the impact that these preferences have on whether or not the world can reach the universal access target. So I'm Dr. Destenie Nock. I'm an assistant professor in engineering public policy as well as civil and environmental engineering. My Twitter is @Destenie Nock. If you want to follow me, here are some more updates. We have a ton more work going on. We are working on autonomous vehicles and understanding the energy impacts of those, as well as the ability for autonomous vehicles to transport essential workers during COVID and during other emergency times. We have a project in sub-Saharan Africa where we are looking at the ability of electrification to aid in agricultural production. We also are doing an entire US-wide sustainability and equity analysis, as well as looking at sustainability impacts from our transmission and distribution systems. So I know I threw a lot at you in a short amount of time, but I hope that you've enjoyed this flavor of the research I'm working on as a new professor in engineering and public policy. Thank you very much.